welcome back to Behind the Tracks. My name is Cynthia and I will be your host today. So today we have a really exciting guest with us. His name is Louis-Pierre Campeau. He's the team lead of our artificial intelligence department here at NewTracks, and he will be talking to us about the function of AI in something like the IoT Hub. I'm really excited to have him today.
Well, thank you, Cynthia. I'm really excited too, and I'm glad to be here to talk about this with you.
Awesome. Thanks for your time. So Louis-Pierre, could you please, in your own words, explain to us what is the purpose of an IoT hub for systems of safety and productivity for underground hard rock mines?
Well, there's really two things that are important in there. It's first on the data side and then on the application. So for the data, especially in the context of Industry 4.0 coming in, there's a lot of importance in collecting the data and analyzing data from different sources. And so what this IoT Hub does is that it brings all those sources and put them in a standard language so that it's much easier to analyze and really collect as a whole. There's like a rule of thumb kind of in data science that says you should spend about 80% of your time on a data science project on just collecting the data.
Wow.
And only 20% on building the actual algorithm. So that tells you how important it is to really have a unique source of data and kind of have clean data coming in. So I think that kind of IoT Hub will really sort of help that and maybe help diminish this 80% of data processing. Then also for data, I think it will ease the sharing. There are more and more applications or more and more push for having open data sets. Like GMG is having one, and I think it's really important to have this common language so that everyone can contribute. Which brings me to my second point on the app side. It means that having this single frame where everyone can contribute and have this open frame especially means that everyone can put their part. And I have a lot of people on my team that are very smart, but there are a lot of other smart people in the world that can also contribute. So rather than having everyone starting from scratch every time, we can just build on top of what's been built by other people. And so it really facilitates this sort of development and make the first step easier. And then on a final note, I would say also it helps on having cross-app applications. Like, for example, if you're using tracking data that is coming from one system and telemetry data that is coming from another system, putting those two data sets together in order to make something for safety or productivity applications could be complex if it was not part of the same IoT hub. But now it really, all the data is coming from the same source, so it eases that process as well.
Thank you for that. That was really interesting. So on that note, could you maybe walk us through what it means to have an AI-powered IoT hub and how this is different than one without any interaction with artificial intelligence or machine learning?
Well, in average, a machine will generate 360,000 points per hour. And so it means that even for small fleets, say 20 equipments, it's more than 7 million data points every hour that are generated by the system. And that's just for telemetry. That's not even including tracking or environmental data. And so you can see that clearly this is too much for a human eye. You could pay a whole team to just look at the data constantly and kind of make calls. And typically, this is what AI has been very good at, kind of extracting the useful information out of a lot of data, and then just showing you what you really need to look at, what requires attention, and leaving the rest behind. And another thing, I think it's also that there are a lot of challenges in playing with data that are kind of unknown. Many people, if you've never played with data, you probably assume that it's, what's this thing with AI? Like, it's super simple. You can make like simple equations. But really, like anyone who says that, I've probably never played with data. Like, just taking the simplest example, we did tests with truck productivity. So we're tracking basically based on the telemetry data, what is the truck doing? So we have its payload, we have the dumper position, we have its speed, all the pressure, temperature, anything you want to know, we know it about this truck. And so one might say, well, it's probably simple to know what the truck is doing if you have that. You have the payload. Every time the payload increases, it means that the truck is being loaded. And every time it decreases, well, it's just done. So simple enough, right? But when we tried implementing simple equations like this, we realized that it was bringing about 70% 70 to 80% accuracy, which is not bad, but definitely like you wouldn't want to get better at this. And even the best equations, like 3-line long equation with a lot of ifs and then and if that, even that, you get to about 90% of accuracy. So there is still some gain to be get. And so with an intelligent system, you really go and get this extra 10% that is out there. Obviously, we don't get to 100%, like nothing's perfect. But from the test we did, we got to like 99.5 more or less. And so that is really bridging the gap. And so why is this? Why are we seeing this 10% gap? It's because there are so much edge cases. It's incredible the amount of edge cases there are, even for simple thing as truck. Like you wouldn't believe the amount of things that can happen. A dumper bed that sort of goes up, goes down, or the key turning off, mixing up with the sensors. The edge cases are really kind of the normal here. And
so what's an edge case? Just because I've never really heard the term before.
Oh, an edge case is kind of an outlier, something that doesn't behave the same way we used to. And so, for example, truck productivity, the normal case would be up and down for loads and dumps. But an edge case could be that midway through the shift, the operator shut down the engine, and so the payload went down, or things like this.
Okay.
Anything that is out of norm.
Okay, thanks.
And so outside of that, because even the edge cases are really generating a lot of, this extra 10% that we're getting, but that's not even including all the faulty sensors, because we need to remember ourselves that we're working in underground mines. And so it's very rough conditions, sensor go haywire, the output data that is clearly, or to human eye, clearly not good. But if you're just using an equation, then how do you know that your payload is not good? So that's something the intelligence system helps. And also it helps with configuration error, because as you're all aware, the more data you have to enter manually, the more typos would happen, the more copy-paste error will happen. And so all of that is simplified into an AI that kind of takes that in consideration for you and helps you not make those same mistakes. So really, I think the edge of having an AI is that it kind of take care of a lot of stuff for you so that you can more easily and faster also get to build the application you want and get the content you want out of the data.
Wow, that's really fascinating. I didn't know all of these things actually could be improved. It's I think it's a big eye opener for most people. So on that front, what are some ways in which AI can help make data collected from IoT systems just more effective in general for uncovering insights about the operations? Like, do you have a few examples you could maybe share with us?
Well, generally, we kind of go for 3 big sectors: production, maintenance, and safety. And so in production, I think the most obvious application is really the tracking of production. Just like in the example before where I was talking about trucks, it's really important to know what your equipment are doing in a first reliable way, that 90% I was talking about, and also real time. So you want to know how does it happen so you can do short interval control and really manage your operation rather than having to wait for the end of the shift to kind of see what happens. And then when you have that for the complete cycle, you can manage the whole thing, but you can also build on top of that to predict the results of the planning even before you actually make it. And then there's maintenance application. There's obviously the condition-based maintenance that can be improved with that, because there's tons of algorithms out there that help predicting when a transmission, an engine, or any part of a machine will break. This is something that come out from other industry, but there's also the preventive maintenance optimization, because you know how they do maintenance every, say, 500 hours or every X amount of fuel burn? Well, this too can be optimized with the power of data. Looking into the previous data, we can make recommendations based on how the preventive maintenance should be operated. And then the final and not least, safety, because I think that in safety, what is so difficult with safety application is to be in the right spot, because obviously you don't want to generate too many false alarms, because then the miners are just not going to listen to your system anymore. But you also don't want to be to kind of on the other side where you're not generating enough alarm, and when something's happened for real, you really want to catch it. So you need to be kind of in this sweet spot in between that really allows you to have the right system. And typically that's what ML has been really good at, kind of finding this sweet spot in between overconfidence and underconfidence.
Wow. Fascinating stuff. Seriously, I think AI and mining is one of my favorite topics for sure. And I think there's so much to talk about. And it would be great if maybe in a couple episodes you could maybe interview someone from your team and we could uncover more stuff about some of the projects that you're working on. I think our audience would really, really enjoy that. So audience, if you want to know more about AI, ML, and mining, please make sure to write us info@newtracks.com. If you have any other topics you'd like us to address, let us know. And I think I'm going to take you up on that and probably have you interview someone else from our team. But thank you so much for the time that you provided us today. We learned a lot, and I think there's much more to learn, and we hopefully will have you again soon on our show. So thank you, Louis-Pierre.
Thank you, and it'll be my pleasure to be here again.